Good morning. No response. Good morning, good morning. At least one response. Okay, more response. Morning, good morning. Okay. So, good morning, good morning, good morning. Yesterday you wait, but there was a problem, some problem. Sir, what is this year physics safe score? That depends upon the paper, na? Suppose the paper is coming difficult, so you are getting less, then it may be the very good score. So that depends upon what is the level of the paper. Safe score is the 180, 160, 170. But that depends upon the paper, because 2008, I said IIT cutoff was the physics cutoff was the 0. So if the paper is difficult, then it may happen. Okay. So I was discussing the string, vibration in the string and all the harmonic everything problem also I completed. I have to discuss the sonometer. Sonometer in detail, there is not required. So sonometer means maybe somebody has done the experiment also for the sonometer. Sonometer, there is a plank, one plank, like a wooden scale, what we are using in the childhood, yellow color wooden scale. On that marking is there like 0, 1, 2, 3, 4, like, okay. So one plank is there. On the plank, string is fixed or wire is fixed. And the other side of the wire, we can hang the different masses, so that we can change the tension in the string. So like, this type of setup is there. In between, two triangular shaped wedges are there, that we call it bridge. So in between, this is called bridge. So what I said, in the sonometer we have the one wire. That wire is fixed at one end. Other end, there is a one hook is there. From the hook we can suspend the different masses. By changing the masses, we can change the tension in the string. Okay. In string, in between there is a two wooden wedges are there. That is called the bridge, and those are movable. We can slide them if we want. We can slide any place. Okay. And this plank is basically, it is a scale. On that marking is there. Like we can get the position of the bridges. Okay. So there is a plank on the plank. There is a marking is there. Okay. So in the sonometer, we so many applications are there. We can find the known frequency of the tuning fork, but that detail no need to go here. What is required? Suppose we hang some mass from the wire. Okay. Then tension in the wire is what? Suppose I suspend the mass m. So tension in the wire is what? Mg. Okay. I'm using the same wire, so mu is what? Constant. Now suppose I am putting the bridges. I put the one bridge here and one bridge here. So what will happen? The whole length, whatever the length of the string is there, that is divided into the three parts. I can say the one part is from here to here, one part is from here to here, and one part is from here to here. So by the wedges, we can divide the whole vibrating length into the three parts. Or we can, if we are putting the bridges at the end, then whole length you will take for the vibration. Suppose this bridge you put here, this bridge you put here, then total length you will take. So by the shifting the bridges, we can divide the whole length. Everybody getting or not? So what is the bridges? Bridges is the wooden, that is the wooden wedge we can say. Okay. So by this we divide the whole wire into the 3 part. Okay, suppose the 3 part length I am taking L1, L2 and L3. Then wire is same, so mu is constant. Suppose I suspend the mass M, so tension is same everywhere. Now tension is same, mu is same, then we can say what? Frequency is inversely proportional to, because formula of the frequency is what? 1 by 2L under root of T by mu. Now here T and mu is constant, then I can say frequency is inversely proportional to length. Then 3 part frequency I can say F1 is to F2 is to F3, that is equal to what? 1 by L1 is to 1 by L2 is to 1 by L3. Okay, sometime they will give the length, frequency ratio, and they will ask the length of the each segment. Then I can say what? L1 is to L2 is to L3, that is equal to what? 1 by F1 is to 1 by F2 is to 1 by F3. Okay, everybody got up to this? So basically they will not go in detail what is the application of the sonometer. They will use the sonometer, but so sonometer means first thing we have to know it is a vibrating string. All the concept of the vibrating string we can apply. The formula what we have learned for the vibrating string we can apply. Okay, next thing they will ask the position of the bridges and all. Then for the same tension and the same wire I can say the F is inversely proportional to L. Okay, here wire they will not change, so that's why mu we have to take constant. Second thing, they will take the same wire, suppose the length they made constant, and they are changing the hanging mass. By changing the hanging mass we can change the tension in the string. We can, like suppose here I suspend the mass M. Suppose I am suspending the M1, then tension I will take M1G. If I am suspending M2, then tension I will take M2G. So like that, if I am changing the mass, hanging mass, then I can change the tension. So same string, same length, constant length, then I can say what? F is directly proportional to under root T. That already we have used. If I am saying same string and same length I am taking, then I can say proportionality is what? F directly proportional to root T. That already we have discussed the question on it. Okay. Everybody got? They say yes or no. Okay. So one small problem. If length of sonometer wire is 110 centimeter and ratio of frequency So here I gave length of the sonometer wire is 110 centimeter and the ratio of the frequency of the 3 segment I gave 1:2:3. Then we have to find the position of the bridges. Okay. So to find the position of the bridges, first we have to find the vibrating length, all the 3 vibrating length. So here I can say what? I gave the frequency ratio, I need the L, then I will use what? L1 is to L2 is to L3, that is equal to what? 1 by F1 is to 1 by F2 is to 1 by F3. Then L1 is to L2 is to L3, what we will get? 1 by 1 is to 1 by 2 is to 1 by 3. Like frequency ratio I gave 1:2:3, then F1 I can take X, F2 I can take 2X, F3 I can take 3X. If I am putting then X, 2X, 3X, then X is the common, so in the ratio we can remove it. So basically what you will get 1 by 1 is to 1 by 2 is to 1 by 3. Okay. L1 is to L2 is to L3 is this. So first it is in the ratio, what? Fraction. Then we have to convert in the what? Simplest ratio. So what we will do? Here LCM is what? 1, 2 and 3 LCM is the 6. So what we will do? We will multiply 6 all the 3. So then what we will get? 6 by 1 that is a 6. 6 by 2 that is 3. 6 by 3 that is equal to 2. Then ratio of the length what we got? 6 is to 3 is to 2. Then L1 what I can say? L1 is equal to 6x. Then L2 I can say what? 3x. Then L3 what I can say? 2x. And sum of the total, like total length is what? 110 centimeter. So I can say what? 6x plus 3x plus 2x, that is equal to what? 110. Okay. So 6 plus 3, 9, 9 plus 2, 11. Then I got 11x is equal to 110. Then x what I got? 10. Why I am taking the x? Because L1 is to L2 is to L3. Ratio is the 6 is to 3 is to 2. Directly I cannot say L1 is the 6, L2 is the 3 and L3 is equal to 2. So that's why any number I to multiply x. So L1 I took 6x, L2 is the 3x, L3 is the 2x. By that ratio is the what? 6 is to 3 is to 2. Okay. Everybody got? So x is equal to 10 I got. Now L1 what I got? L1 is equal to 60 centimeter. Then L2 what I got? 30 centimeter. Then L3 what I got? 20 centimeter. These are the 3 length I got. Okay. But I'm not asking the length of the 3 segment. I'm asking the position of the bridges. I'm asking position of bridge. Then what we will do, what I said, in the sonometer, that wire is fixed on the plank. Plank means scale. Okay. So first length I am getting at 60 centimeter. So first bridge I will put at 60 centimeter. First bridge I will put at 60 centimeter. Second vibrating length I am getting 30. Second I am getting 30 in between. So means this distance between the first and second bridge is 30. So at which place you will put the second bridge? You will put at the place 90 centimeter mark. I will show. Suppose here. This is the wire. Okay. So first length I got what? 60 centimeter. So first bridge I put at 60 centimeter. Second length I am getting 30. 30 means the distance between first and second bridge is what? 30. Okay. So this is the scale 0, 1, 2, 3, 60, 70 like that it is there. Okay. So second length I am getting 30. So where I will put the second bridge? I will put the second bridge at the 90 centimeter mark. Okay. So first bridge I will put at the 60 centimeter mark. And second bridge I will put at the 90 centimeter mark. Now from that I can say L1 is equal to what? 60, L2 is equal to what? 30, L3 is equal to what? 20 centimeter. Everybody got or not? Length I am asking separately, then that is a 60, 30 and 20. But I am asking the position of the bridges. So one bridge I will put at the 60 centimeter mark and one bridge I will put at the 90 centimeter mark. Everybody understood or not? Completed? Now next topic is what? Vibration of air column in the organ pipe. So basic organ pipe idea everybody has. What is the organ pipe? Organ pipe means you know that it is a two type. Simple normal pipe we can say organ pipe. Uniform pipe is the organ pipe. We learn two types of organ pipe. One is the closed organ pipe. One is the open organ pipe. Closed organ pipe is what? It is a closed at one end, open at other end. Closed at one end, open at other end. Okay. And open organ pipe means what? It is a open at both end. Open at both end. Everybody getting or not? So normal pipe, what we are using in the home for the plumber purpose, then it is what? Open, you can say the open because it is pipe is open at both end. And closed or pipe, like suppose you have the one bottle, water bottle. That water bottle you can consider like a closed organ pipe because bottle one end is closed. Okay. So closed organ pipe, it is a open at one end, closed at other end. And open organ pipe, it is a open at both end. Okay. In organ pipe, we study the vibration of air because in the pipe, like suppose you have the one pipe, In the pipe, what will be there? Air is there. So we are studying the vibration of air in the pipe. Okay. So suppose you have the one organ pipe and you produce any sound on the one end. You produce any sound at one end. Then what will happen? Sound will travel through the air inside the pipe. Okay. Then it will get reflect from the other end. When it will get reflect, now in the pipe, how many waves are there? One wave is going, it incident. One wave is reflected. So in the pipe, we will have the basically what? Two waves, or we can say waves that is traveling in the opposite direction. So when the waves equal frequency, equal velocity, same speed, they are traveling in the opposite direction, so they will form the standing wave. Okay. So if I'm saying inside the organ pipe, which wave is formed? Which wave is formed? Then standing wave is formed. Which standing wave form? Then it is a longitudinal standing wave. Why? It formed due to the superposition of the two longitudinal waves. Like in the string we have learned, it is a transverse standing wave. Why? It was formed due to the superposition of the two transverse wave. Okay. But here the standing wave is formed due to the superposition of two longitudinal waves. That's why it is called the longitudinal standing wave. Everybody got or not? So in the organ pipe, suppose they are asking which wave will form inside the organ pipe, then longitudinal standing wave will form inside the organ pipe. Okay. Up to this, okay. So inside the organ pipe, longitudinal standing wave will form. Now, suppose I am saying the length of organ pipe. So length of organ pipe means we are not taking the pipe, how much length of the pipe we are taking. Basically what I said, length of the organ pipe. In the organ pipe, who is vibrating? Air is vibrating. So when we are saying the length of the organ pipe, so basically what is the meaning of that? It is the length of the air column, length of the air column inside the pipe. Okay. So like suppose I am saying I have the one closed organ pipe of length 2 meter. I have one closed organ pipe of the length 2 meter. Now 0.5 meter of the pipe I filled with water. 0.5 meter I filled with water. So what is the length of the organ pipe I will take? So length of the organ pipe, basically pipe length, what I gave 2 meter. But what I said in the here when we are saying the length of the organ pipe, it means what? We are taking the vibration of the air column. It means we have to take the length of the air column. Now what is the length of the air column? We will take 1.5 meter. Okay. Everybody getting or not? Okay. Understood or not? So means length of the organ pipe means what? Length of the air column. Okay. Okay, then everybody understood now. Okay now. So length of the organ pipe is the length of air column. Now what I said, we have the two types of organ pipe. One is the closed organ pipe, one is the open organ pipe. Closed organ pipe, at that is the one end, it is a closed. So already I discussed rigid boundary or the denser medium. Rigid boundary means that we will get what? Node there. Okay. So in the organ pipe at the closed end, we will get the node, displacement node. Again I am repeating, at the closed end we will get the node. At open end, air particles are free to oscillate. That at open end what we will get? Antinode. So again I am repeating, at the closed end we will get the node, at the open end we will get the antinode. Okay. and open and antinode. Okay, so these things, basic thing that we have to remember for the organ pipe. Okay. Now next is what? Closed. So closed organ pipe, that is we have to discuss the fundamental frequency. So already all basic definition, everything I have explained. So now I'm not going to explain again, and little bit I will go fast also for this. Here I'm saying what already I said, fundamental frequency means we will take the minimum number of nodes and antinodes. Okay, then the frequency of oscillation will be the fundamental frequency. I'm discussing first for the closed organ pipe. So closed organ pipe, one end closed, one end open. Okay, minimum number of the node and antinode we have to take in the fundamental. Okay, so at closed end we are getting node, at open end we are getting antinode. Okay, then that is a minimum. Less than that can I take? No, one node, one antinode. Node and antinode has to be there. One node, one antinode. That is a minimum possibility of the node and antinode. Then it will, in the fundamental mode, what we will have? We will have one node, one antinode at open end antinode, at close end node. Okay, like in the string we have learned, it was fixed at both end. So both end means node and node. So two node were making the one loop. Okay, but here one end is open. One end is open, then closed loop will not be there. Closed loop will not be there in the fundamental. Okay, so in the organ pipe, definitely one half loop you will get. Okay, so because the node and antinode will not make the complete loop. Everybody getting or not? So then how it will vibrate? It will vibrate like in a half loop. We can say it will like this. Okay, are everybody getting or not? Like in the string, node and node, it was fixed at both ends. So node and node, they were making the one loop. So fundamental we got the one loop, but here node and antinodes are there, so they will not make the complete loop. Getting or not? And we know the distance between the consecutive node and antinode is what? Lambda by 4. And the length of the pipe, suppose I am taking L. So from this what I can say? Lambda by 4 is equal to L. Then lambda by 4 is equal to L. Then lambda what I can say? Lambda is equal to 4L. Or that is the maximum wavelength we can get. I said in the string, like maximum wavelength we are getting 2L. Here I can say the maximum wavelength we are getting the 4L. Up to this, okay? Now fundamental frequency, what I can write? F naught is equal to V by lambda, that is equal to what? V by 4L. So this formula we will remember for the organ pipe. Fundamental frequency is what? V by 4L. This everybody got? What is a V here? There V was the velocity of that transverse wave. Here this is formed due to the sound wave. So that is what? V is the velocity of sound in, V is the velocity of the sound in air. Okay, and that formula we learned, V is equal to under root of gamma RT over M. Okay, generally we are using under root B by rho for the solid and liquid, and the already I said for the gases and the air we got the bulk modulus is the gamma into pressure. Then from that we are using for the air and the gas particularly we are using what? V is equal to under root gamma RT by M. Okay. Completed. So fundamental frequency we got V by 4L. Now after the fundamental we will have the first overtone. First overtone means what I said, one overtone added means what? Basically one node, one antinode we are adding in the previous one. Okay. Everybody getting or not? In the organ pipe or the string also I said one node added means one overtone added means one node, one antinode added. Okay. So earlier I have in the fundamental I have one node, one antinode. Now first overtone means I will add one node and one antinode. Okay. Then this is antinode, this is node. In between I have to add one extra node. Okay. So suppose I added one node. I add one node, one antinode will be extra, it will be there in between. Okay, so you added one node, then one antinode is also there. Okay, so earlier one node, one antinode. Now how many node we have? Two node and two antinode. It means one node, one antinode we have added. Okay, node and node will make the one loop, then node to node, one loop. It will vibrate like this. Okay, everybody got or not? Now listen. In the case of the organ pipe, if we are getting the complete loop, that complete loop is coming due to the overtone. Okay, because fundamental no complete loop is there. So how many complete loops will be there? That is a number of overtone directly I can say. Okay, in the figure they will give how they may ask which overtone it is a vibrating, which harmonic it is a vibrating. Then complete loop is coming due to the overtone. So here I am getting one complete loop. It means it is a what? First overtone. Everybody got or not? So complete loop will come due to the overtone. Number of complete loop is the number of overtone directly we can say. Okay. Now in that case, what I will say, node to node distance is what? Lambda by 2, and node to antinode distance is what? Lambda by 4. Okay. Now lambda by 2 plus lambda by 4, lambda by 2 plus lambda by 4, that is equal to what? L. Then 3 lambda by 4 is equal to L. Then lambda what we got? 4L by 3. Okay. Lambda you got 4L by 3. Now after putting then fundamental frequency of first overtone, what you will get? V by lambda means 3V by 4L. 3V by 4L is what? 3F0. I will not show for the second and all. Directly from this we will generalize. So this is the what? First overtone. This is the first overtone and third harmonic. Why? Which multiple of fundamental? Third multiple of fundamental. So that is called the third harmonic. Everybody got? Already I said all these concepts. So it is what? First overtone and third harmonic. Completed. Now from this directly we can generalize now. Fundamental, okay, F0. Then first overtone I am getting the 3F0. Second overtone we will get the 5F0. Third overtone we will get the 7F0. Fourth overtone we will get the 9F0. So from that we can say what? Overtone and harmonic. What is the relation? Harmonic is equal to, suppose overtone I am saying N. Nth overtone. How many harmonics are there? 2N plus 1. 2N plus 1. Like first overtone, third harmonic. Means 2N plus 1 means 2 into 1 plus 1, 3. Second overtone, fifth harmonic. 2 into 2 plus 1, fifth harmonic. Third overtone, 2 into 3 plus 1, seventh harmonic. So overtone and harmonic, what is the relation for the closed organ pipe? 2N plus 1. Okay. Then I can say what? Frequency of nth overtone. That is equal to what? 2N plus 1 into F0. Okay. Directly I am general, because second I can show. Now you can make the another one loop. Then after that you will find the lambda. After finding the lambda you will get the second overtone frequency. You will get 5F0. Okay, so like that we can generalize nth overtone. What is the frequency? 2N plus 1 F0. Completed. Then now some points. So if I am saying how many overtones? N overtone. N overtone is equal to how many harmonics? 2N plus 1 harmonics. Okay. So if suppose I am saying the nth overtone, then directly harmonic number I can say 2N plus 1. If harmonic I gave and I'm asking the overtone, then harmonic is equal to 2n plus 1. Then from that I can find the n. So if overtone they given, directly 2n plus 1. Okay. If they given the harmonic and they are asking overtone, so harmonic is equal to 2n plus 1. Then overtone, what you will get? Harmonic minus 1 by 2. Okay. This everybody got. And that I said harmonic number will be always more than the overtone. Okay. This, okay. N overtone means how many complete loops are there. N overtone means what I said, complete loop is coming due to the overtone. N overtone means how many complete loop will be there? N complete loop will be there. So this I can say what? N complete loops added in fundamental. Okay. Number 2. Now listen. Same I explained earlier also how to find the number of node and antinode. I said when we are going through the formula, so we have to remember the separate formula for the string. We have to mug up the separate formula for the open organ pipe and for the closed organ pipe. Okay. But what the logic I said, how we can find directly by without using any formula. So suppose I am asking the number of node and antinode. Okay. Number of node and antinode in the 7th harmonic in the closed organ pipe. I'm asking number of node and antinode in the 7th harmonic of the closed organ pipe. Who will say the answer? Tell fast. Number of node and antinode in the 7th harmonic in the closed organ pipe. Number of node and antinode. Tell fast. Number of nodes and antinodes in the 7th harmonic of closed organ pipe. 4, 4. 4. Very good. Arey na like 7, 7. Who is saying 7? 4, 4. Very good. 4. What I said, if they given the overtone, very good. If they have not given overtone, they given harmonic. So first we have to find the overtone. Number of overtone is the number of node and antinode added in the fundamental. Fundamental we have to keep in the mind. In the closed organ pipe, fundamental 1 and open, 1 and closed means 1 node and 1 antinode. So first, if they given overtone, very good. Not given, then first find the overtone. After getting the overtone, that number of node and antinode added in fundamental. Fundamental we know that 1 node and 1 antinode is there. So I gave 7th harmonic. 7th harmonic means which overtone? 3rd overtone. 3rd overtone means 3 node, 3 antinode added in fundamental. Fundamental 1 node, 1 antinode. So total node 4. Total antinode 4. Everybody got or not? I explain in the string also. So here I can say what? Nth overtone node is equal to n plus 1. That one we are adding for the fundamental. Everybody got? Now number 3. In closed organ pipe, frequencies how we are getting, like I got fundamental F0. Then next frequency I am getting what? 3F0. Next frequency what I am getting? 5F0. Next frequency what I am getting? 7F0. Like that we are getting the frequencies. Okay. If you see this frequency, then 1F0, 3F0, 5F0, 7F0 is coming. It means in the closed organ pipe we will get only odd harmonics. In the closed organ pipe we will get odd harmonics. Only odd harmonics are obtained in the COP. And if you see the any two consecutive frequency, like suppose you are taking 5F0, 7F0, 7F0 or 9F0, then the difference of the consecutive frequency will be 2F0. Earlier in the string it was the F0, but here difference is 2F0. Okay. Okay. So this is the all theory about the closed organ pipe. Okay. Now next is what? Open organ pipe. So open organ pipe, it is a open at both end. Then how it will vibrate in the fundamental? It is open at both end, means here open end antinode, here open end antinode. Between the two antinode, minimum one node will be there. And fundamental, we have to take the minimum number of node and antinode. So these antinode will be there, that we cannot remove. Okay. And in between the two antinode, one node will be there. So minimum possibility is what? Two antinode, one node. Okay. Then how it will vibrate? Like this. Okay. Here also we will not get the complete loop because antinodes are there at the both end. Okay. Now this is the fundamental of the organ pipe, open organ pipe. Now distance between consecutive antinode and node is what? Lambda by 4. Then here also it is what? Lambda by 4. Now I can say what? Lambda by 4 plus lambda by 4 is equal to L. So lambda by 4 plus lambda by 4 is equal to L. Then lambda what I got? 2L. Okay, lambda we got 2L. Now fundamental frequency, what I can write? Fundamental frequency F naught is equal to what? V by 2L. Okay. Remember that whatever the result we will get we got for the string, similar result we will get for the open organ pipe. Okay, we got the, like for the string we got V by 2L. Here also we are getting the V by 2L. Only the difference of the V is there. That V was the speed of the transverse wave. Here this V is the speed of the sound wave in the organ pipe. Okay, everybody getting or not? So result of the open pipe and result of the string, that will be similar. Okay, closed organ pipe, it is a different. And that you can relate also, like any musical instrument. We are using guitar, we are using sitar, that wire is fixed at both ends. Or we are using the flute or the trumpet, they are the open organ pipe. So all the musical instrument, we are using either the open organ pipe or we are using the string fixed at both ends. Because both will produce the both even and odd harmonics. More harmonic than sound will be the pleasant. Okay, so that's why you can remember open organ pipe, musical instrument we are making for the open organ pipe or the vibrate string fixed at both ends. That's why their results are similar. Understood or not? Fundamental frequency same formula we are getting, what we learned there, only the difference of V is there. Okay, open organ pipe will also produce the both even and odd harmonic. Difference of the consecutive frequency will be F naught. Everything will be same. One difference is there in the string fixed at both ends. We got the fundamental, we got the two node, one antinode. Here difference is there. In the fundamental, we are getting two antinode, one node. So node number and antinode number got reverse with respect to what? String fixed at both ends. Everybody getting or not? So open pipe and that result will be similar. After that, first overtone, how we will get? Now everybody can do by own now. First overtone means you will add one node and one antinode in between. So when you will add one node and one antinode, then like this, here antinode, here antinode. In between one node we have to add. So I added one node. Okay, now how many nodes are there? Two. Earlier how many nodes was there? One. Okay. Now how it will oscillate? Node to node, one loop. So how many antinode we have now? 3. Earlier how many we have? 2. So one antinode added and one node added. So basically one complete loop added. So in the organ pipe, complete loop means what? Number of overtone. Everybody got or not? So then how we can find the frequency? This is what? Lambda by 4. This is what? Lambda by 2. This is what? Lambda by 4. So lambda by 4 plus lambda by 2 plus lambda by 4. What I will get? Lambda is equal to L. Then frequency of first overtone. F1, what I can say? V by L. But I said we will not mug up that. Multiply with 2, divide with 2. No change. V by 2L. V by 2L, what I can write? Fundamental. Then I can say what? F1 is equal to 2F0. So means it is the first overtone and second harmonic. I think everybody getting, because everything I explained clearly in the before starting the string. So now we can do fast. Okay. So this is the first overtone and second harmonic. Okay. Now all those results directly we can write nth overtone. Nth overtone is equal to what? N plus 1 harmonic. That same I got in the case of the vibrating string also. Okay. And that is equal to what? N complete loop added. Okay. Second thing I can say nth overtone. How many nodes, how many antinodes? So overtone means number of node and antinode added in the fundamental. Then nth overtone means how many nodes? N overtone means n added. Fundamental, how many node? One node is there. So number of nodes, what I will get? N plus 1. And antinode. So n added and in the fundamental 2. Here node and antinode number got reverse in with respect to what? String. So fundamental 1 node, okay, and n added, because nth overtone means n node is added. So n plus 1. Antinode, nth overtone, antinode means what? N added, and fundamental, how many antinodes are there? 2. Then what is the number of antinode? N plus 2. Six node, 7 antinode. Without asking the question, how you are getting the answer? Shiva, this answer is for which question? You are saying 6 nodes and 7 antinodes. For which question? Answer you are saying, question I have to make. You are saying the 6 nodes and 7 antinodes. Okay. So here, how we are getting the frequencies? F0, then we are getting 2F0, then we are getting 3F0, dot, dot, dot. Then I can say both even and question from the last class. Both even and odd harmonics are obtained. Okay. Then difference of the consecutive frequency is what? Delta F, I can say what? Consecutive frequency difference. These results are same. Most of the, you can see also all the result is same. Only one difference is there in the nth overtone, number of node and antinode got reverse. Okay. Otherwise, all the results are same as the string. Okay. So this is the theory for the both closed and open organ pipe. Resonance tube and the correction, those problems right now you will not do. Next week I will try to add that experiment, because at least it will take 1 hour to explain what is a resonance tube and everything. So resonance tube we will not do in this week. Okay. we will do the simple closed organ pipe and open organ pipe question. Okay, beats we will complete. Next class I will try to complete the beats. Okay, so after that, next week I will try to include the resonance tube. Okay, because that experiment is important. JEE Main they are asking every year. Okay, so end correction problem, resonance tube, resonance length, that type of question is there, then you can leave it. Okay, simple organ pipe based question we will do. Okay, now some problems. Okay, so which harmonic it is? Which harmonic I have shown? This vibration shows which harmonic? Tell fast. This vibration shows which harmonic? As question complete, immediately the people will say the answer without thinking anything, means what I said, what you have learned, without thinking directly 5. Okay, 9, 9, 9, 9, 9, very good. So what I said, complete loop in the organ pipe is the overtone. Complete loop is coming due to the overtone. Okay, how many complete loops? Somebody is unable to count also because due to the morning. So how many complete loops are there? 1, 2, 3, 4. 4 complete loops means complete loop will come due to the overtone. It means which overtone it is? Fourth overtone it is, because half loop we will get in the fundamental. So 4 complete loop means it is a fourth overtone. Okay. Fourth overtone means harmonic. What I can say, harmonic is equal to 2n plus 1, because it is a closed organ pipe. You can see it is a closed at one end. So it is a closed organ pipe, harmonic and the overtone. What is the relation? Harmonic is the 2n plus 1. Then overtone I got 4. So 2 into 4 plus 1, that is equal to what? 9. So it is a 9th harmonic. Harita, sleep, it is better. Why you are getting 6? Murali, Harita, now corrected. Okay. What I gave here, if the second overtone of the closed organ pipe is equal to the third overtone of open organ pipe, if length of the open organ pipe I gave 80 centimeter, then we have to find the length of the closed organ pipe. If you can try, you have 1 minute, tell fast. $50. So what we will do here, second overtone of COP. Second overtone of COP means fifth harmonic of the closed. I am writing as a 5 FC because second overtone means 2n plus 1, then you will get fifth harmonic. Harmonic number, then directly will multiply with fundamental. So that I write 5 FC. FC means fundamental of the closed organ pipe. Okay. Otherwise FOC you can write. That is equal to what? Third overtone of open. Third overtone of open means fourth harmonic. So fourth fundamental of open pipe. Okay. Now formula of the closed organ pipe fundamental V by 4L, that will be V by 2L. Now 5 into closed organ pipe V by 4 LC I am writing. LC means length of closed organ pipe. That is equal to what? 4 into V by 2 length of open organ pipe. Okay. Now V and V get cancel out. This 2 and this cancel out. I gave LO, I gave LC I am asking. So LC what I will get? LC is equal to 5 LO by 8. LO I gave, length of open I gave 80 centimeter. Then 5 into 80 by 8. That I got what? This become the 10. Then we got 50 centimeter. So what is the length of the closed organ pipe? 50 centimeter. Okay. Suppose I am asking how many nodes and antinodes are there in the given overtones. You have to say the number of nodes and antinodes in the given overtone. Tell fast. How many nodes and antinodes are there in the given overtone? In the given overtone, tell what is the number of nodes and antinodes. Given overtone, number of nodes and antinodes. So I gave the second overtone of closed. Second overtone of closed means 2 node, 2 antinode added in the fundamental. Fundamental of the closed is what? 1 node, 1 antinode. 1 node and 1 antinode. Yeah, still the people has the problem is randomly they are saying the any answer. First thing then and you have to say the answer, no? I am saying the overtone. Infinite time I said overtone, we will directly go to the overtone. Overtone means number of node and antinode added. Now we are taking the harmonic again and again. Overtone means number of node and antinode added in fundamental. Number of node. So closed organ pipe I gave the second overtone. Second overtone means 2 node, 2 antinode added. In fundamental. Fundamental how many nodes are there? 1 node. How many antinodes are there? 1. Then how many total we got? 3 nodes and 3 antinodes in the closed organ pipe. Open I gave third overtone. Third overtone means 3 node, 3 antinode added in fundamental. Fundamental, how many nodes and antinodes are there in open? Open 2 antinode, 1 node. Okay. So 3 added, fundamental 2. Then total number of antinode is what? 5. And node is equal to what? 4. So directly I said what? We have to go through the what? Overtone. From the overtone it is easy. Okay. So these are like when you are doing like harmonic directly you are adding then what will happen? You know the thing, but due to the hurry what you are doing, you lost the question. So first we have to think means okay what they given, harmonic they given or overtone they have given, accordingly we have to say the answer. Randomly means like directly harmonic, overtone, whatever, we will add the fundamental. What I said, first harmonic given, first convert into the overtone because that will be easy. Otherwise 12 formula you have to mark down and in the exam you will get confused. Physics is not all about the formula. Okay. Now next problem. Tell fast. Answer you have to give in the terms of F. If open organ pipe frequency is F, if 1/3 length immersed in the water or filled with water, then we have to find the frequency of the pipe. 3f by 2, 3f by 2. Arey nalayak. Now listen, earlier it is an open pipe. Okay, now what happened? You filled the 1/3 length in the water. Suppose 1/3 length is occupied by water, L by 3. Then what I said, in the organ pipe, we are considering the length of air column. Okay, we are considering the length of air column. Now initial frequency when it was open, so F I gave open pipe frequency is what? V by 2L. So basically F value is what? V by 2L. Okay, because the frequency of open pipe I gave F. Now when I filled the 1/3 length with the water, then now it is a closed organ pipe. It become, who is saying the answer 3f by 2? They have taken the length only, but they have taken the open organ pipe. When you fill the one end with the water, now one end become closed. One end become closed, so it become the closed organ pipe. It become the closed organ pipe of length 2L by 3. It become the closed organ pipe of length 2L by 3. Now you can see now, this is the air column, this is the air column. So what is the length of this air column? 2L by 3. And one end is closed, so it is a COP. It is a closed organ pipe of length 2L by 3. Okay. Now F dash, or F, I am saying F dash is equal to what? V by 4. Length is what now? 2L by 3. Then 3 will go up. So 3V by 4 into 2L. Okay. Now V by 2L. V by 2L is what? V by 2L is equal to F. So V by 2L is equal to F. Then what we got? 3F by 4. Then what is the frequency of that? 3F by 4. Okay. If suppose they are saying the half length is immersed, then everything will be same like here. You will take the L by 2 inside, L by 2 in the air. So we will take the closed organ pipe of length L by 2. Then here I will write 4 V upon 4 into L by 2. Then I will get V by 2L. V by 2L means frequency will become F. Okay. That they ask in the NEET also. So everybody got, if half length has immersed, then we will take what? Immersed length is the L by 2. So how many length? What is the length of the air column? Length of the air column will be L by 2. Then same thing we will do, and you will get the frequency what? F. Some intelligent people, they think that suppose this type of question has given. Okay, open organ pipe of the frequency F. Now this length is immersed in the water, then what is the frequency? Increase, decrease, remain same, like suppose they are saying. So somebody will say frequency does not change with the medium. So now here the organ pipe is immersed in the water, but the frequency will not change. So they will go to the answer remain same. Okay, but here I said what? When the wave is going from any wave you created, that point also you have written in the notes. When after creation of the wave, when the wave is going from the one medium to another medium, then frequency does not change. Frequency does not change because frequency depends upon the source. Frequency depends upon source. In this problem, you have not created the wave. You have not created the wave. I am saying the wave is going from the one medium to another medium. Here, you are changing the source. Earlier, you have the open organ pipe of length L. Now you have the closed organ pipe of length 2L by 3. Source has changed. Frequency depends upon the source. Source change, that's why frequency is getting what? Frequency become different. Everybody got or not? So don't use your mind like frequency does not depends upon the medium. So that is what one wave is going from one medium to another medium, then frequency will remain same. Okay. Completed. So next problem, if open organ pipe of length 30 centimeter resonate if it is COP, then which harmonic? So here they are saying velocity of sound I am giving 330 meter per second. So they given what? There is the open organ pipe of length 30 centimeter. It resonate with 1.1 kilohertz. Resonate, what I said, when the two body, I am saying this body resonate with this body, it means the frequency of both are equal. Okay. So here I am saying the open organ pipe of length 30 centimeter, it resonate with 1.1 kilohertz. It means frequency of the open pipe is equal to 1.1 kilohertz. Then they are saying which harmonic it will happen, which harmonic of the open organ pipe it will resonate with 1.1 kilohertz. Okay, resonating means frequency is equal, but frequency, that frequency is the fundamental frequency of the open organ pipe, or the second harmonic, or the third harmonic, or the fourth harmonic, that they are asking. Okay, second part what they are asking, in the place of the open, suppose the same we have the closed, then which harmonic the closed will resonate with the same frequency 1.1 kilohertz. Okay, if COP of same length you can write. Okay. Now here they are asking the harmonic, which harmonic it will resonate. Two options are there. First I will find the fundamental frequency of the open. Fundamental frequency, after finding fundamental we will check that which harmonic you will get. Okay, so fundamental frequency of the open, F naught of open, that F naught I can say what, V by 2L. Okay, V by 2L means now V what I gave 330 upon 2, L I gave 30 centimeter means 0.3. Okay, then that you will get what, 1100 by 2, or I can say 550 hertz. Okay, so fundamental frequency of the pipe what I got, fundamental frequency of the open pipe I got 550 hertz. They are asking to resonate with 1100. So frequency of the open pipe has to be equal to the what, 1100. So which harmonic it is? Which harmonic? 550 into 2. So nth harmonic means n into 550. What I can say, n into 550 has to be 1100. Then from that n value what you will get, 2. It means second harmonic of open pipe will resonate with 1100 hertz, because 1.1 kilohertz means 1100 hertz. Okay. Okay. Then for the closed, what you will get? For the closed organ pipe, same way you will find. Then fundamental frequency, you will say what? V by 4L. Okay. Then number of harmonic, you will get what? 4. So means for the closed organ pipe, it will be the fourth harmonic. But fourth harmonic is not possible in the closed organ pipe. Fourth harmonic is not possible in the closed organ pipe. Then what is the answer? Speed I gave. In the problem I gave speed of the sound in the air. I gave 330 meter per second. Gitanjali. Okay. So here by solving n value, what we are getting? 4. So what is the answer? Which harmonic of the closed it will resonate with 1.1 kilohertz? Which harmonic of decimal I remove. Gitanjali, this decimal I remove, I make it 3300. While solving, that was 0.3 because 30 centimeter means 0.3 meters, 0.3 and then I made it 0. Okay. So which harmonic? What is the answer for the closed organ pipe? After solving, we are getting the fourth harmonic. Then what is the answer? Fourth harmonic can we get in closed organ pipe? No, fourth harmonic, only odd harmonics are obtained. Only odd harmonics are obtained in the closed organ pipe. So what is the answer? For the same length, for the given length of the closed pipe, it has to be fourth harmonic. Like they are saying third harmonic. Third harmonic, how you will get the frequency is equal to the 1100. Third harmonic, you will get the frequency 1100. No, which harmonic you will get the frequency 1100 for the fourth harmonic. But fourth harmonic is not possible in the closed organ pipe. It means closed organ pipe of length 30 centimeter cannot resonate with 1.1 kilohertz. Yeah, they are adding +1, -1. They are doing one. This I am getting, so this is not possible in COP. This is not possible in COP. It means above step is not possible. Above step is not possible. So above step, what I did, I equated the possible frequency of the COP with 1100. So n is equal to 4 not possible. Then it means frequency of COP is 1100 not possible. It means what? COP of length 30 centimeter cannot resonate with 1.1 kilohertz. Answer is not the 3 and 5. I will do subtract 1 and I will add 1. Mathematically, and we are getting 4. Okay, when you are taking 3, who is saying the answer 3 or 5? You will multiply fundamental with 3 or 5. Will you get 1100 hertz? No. Who is saying the answer 5? If you are taking 5 into fundamental of the closed organ pipe, will you get the 1100 hertz? No. Who is saying the answer 3? When they multiply 3 with fundamental, they will get the 1100. No. It means fourth is only the 4. Mathematically, we are getting fourth. Fourth harmonic frequency of this COP will be equal to 1100. Only one possibility is there, n is equal to 4. But n is equal to 4 is not possible. That's why resonance is not possible. It means what I can say, this closed organ pipe of length 30 centimeter cannot resonate with 1100 hertz. Everybody understood or not? Don't change the answer anything. We are getting 4, but 4 is not possible. That's why it will not resonate. Like this case, suppose I am getting n is equal to 4. So n is equal to 4 not possible. So this not possible. This not possible. So this not possible means resonance is not possible in the case of COP. Understood or not? Tell fast. Okay. Now last. So here what I gave, if the fundamental frequency of the closed organ pipe is the 1500 hertz, then we have to find the total number of natural oscillation a person can hear from this organ pipe. Okay. So normal person can hear up to the what? 20,000 hertz. So what is the fundamental frequency of the COP I gave? 1500. Okay. So then I'm asking how many total oscillation the person, normal person can hear from this organ pipe. So like this organ pipe, fundamental is the minimum frequency is the fundamental. That is a 1500 hertz. Next, it will produce 4500 because 3F not 4500. Next, then 5 times means 7500. Like that way, up to the 20,000, how many frequencies will come? That the person can hear, because beyond the 20,000 the person cannot hear. Okay, this type of problem, common procedure is there. If they are asking the total number of natural frequencies, it means it is total number of natural frequency means including the overtone and the harmonic. Overtone does not include that fundamental. Okay, so what we will do, we will calculate the overtone number, total overtone plus one fundamental. That will be total number of natural oscillation. I repeat again, this type of problem, we will calculate the overtone. Suppose I got the 10 overtone. So 10 overtone and one fundamental. So total how many frequencies the person can hear? 11. Okay. If they are asking how many total overtone the person will hear, then only we will calculate the overtone. If they are asking total number of natural oscillation, then we will add 1 in the overtone. Everybody getting or not? So total oscillation, then we will find the overtone plus 1. So overtone only they are asking, so we will calculate overtone. Okay. So what we will do in that case, suppose I am saying total n overtones are there. Total n overtones. So n overtone means which harmonic? N overtone means 2n plus 1 harmonic. Why? Because I gave the COP, I gave the closed organ pipe. So n overtone means 2n plus 1 harmonic. Now harmonic number when you know, so directly I can write the frequency. What? 2n plus 1 into fundamental, that must be less than or equal to 20,000 hertz. Okay, that is a like say common procedure that for this type of question. 2n plus 1 f naught means frequency of the nth overtone. Maximum suppose it can hear n overtone, so frequency of the nth overtone has to be lesser than or equal to 20,000. It should not cross 20,000. That's why I have written less than or equal to 20,000. Okay. Now fundamental I gave 1500. So fundamental 1500, then I can say what? 2n plus 1 into 1500. It should be less than or equal to 20,000. Then 1 0 2 0 cancel out. 5 3s are 5 4s are means 40. Then 2n plus 1 I got less than or equal to 40 by 3. Okay. Up to this everybody understood. So 2n plus 1 I got less than or equal to 40 by 3. 2n plus 1 is the harmonic. 2n plus 1 is the harmonic. Harmonic will be 1 2 like this, 1 3 5 7. It will be integer. Okay. 40 by 3. 40 by 3 you will get what? 3 1s are 3, 3 3s are 9, 3 3 like this you will get. Okay. So that is a what? 40 by 3 we are getting 13.33. But I have to take the integer. I cannot directly equate the 2n plus 1 is equal to 40 by 3. Okay. I cannot directly equate 2n plus 1 with 40 by 3. 40 by 3 I am getting 13.33. 2n plus 1 is integer. So nearest integer what you will take? Nearest integer what you will take? We will not directly equate with 40 by 3, but because 40 by 3 is not an integer. So nearest integer what I will take? 13. Everybody getting or not? 14, who is saying nalayak? 14 when you are taking, so you will cross that 20,000. You will cross that 20,000. 20,000 I cannot cross. Less than 20,000 is acceptable, but more than 20,000 is not acceptable. Even you are getting the 13.9, even you are getting 13.9, then also you will take the 13. Why? Because 14 if you are taking, then you will exceed the 20,000. So even you are getting 13.9 also, we will not take 14, we will take 13. One thing. Second, suppose here I am getting that 12.33. Suppose here I am getting, first listen, then we will write the answer. Suppose I am getting 12.33. 12.33. Then what you will take? You are getting 12.33. Then what you will take? $11 we will take. Why? Not 12, not 12. Why? 12 is the even number, 2n plus 1 is the odd number. 12 is the even, 2n plus 1 is the odd. So when you will equate with 12, you will get number of four tone in the decimal. Number of four tone will be 1, 2, 3, 4, 5, 6. So like suppose I am getting the 12.33, then next integer, previous integer is what? 12. But 12 I cannot take because 2n plus 1 is odd. Then I will take 11. Everybody getting or not? So then here directly I will write what? 2n plus 1 is equal to 13. Now 2n I got what? 12. Then n what I got? 6. So 6 overtone. Then total frequency. Okay. Everybody got? Means right, left hand side odd integer is there, so right hand also we will equate with the odd integer only. Okay. Now you can solve all the problems of the organ pipe. Okay. Then next class possible. Then beats and some small concepts are there in the organ pipe that I will discuss next. Okay. Okay. Then bye bye. You can take the breakfast. Anybody has doubt in this? I will send the notes in the group. Now, in that case, frequency decreases only, we cannot say. Okay, next class I will discuss frequency not only decreases. In the beginning it will decrease half image, then it will become equal. After that it will increase. Okay, you can check also. Suppose L by 3. When L by 3 image, then frequency you are getting 3f by 4. When L by 2 image, then frequency you will get f. When more than that image, then frequency you will get more than f. So in the beginning it will decrease up to the half. Then more than half, then frequency will start increasing. Okay.